Okay, tutorial 4, chapter 4, sketching organic molecules in 2D. Let me just remind everyone where this tutorial can be located. If you go to the activities menu in the upper right corner of Spartan and then go to tutorials, and let me just make this a little bit larger. It's the fourth tutorial down, sketching organic molecules in 2D. Okay, so we'll leave this sort of 3D environment and move to a 2D building environment. And the way one does that, and I'll move the instructions off to the side in just a second. The way one does that is via either the File menu, New Sketch, or via the second entry, New Sketch. It sort of looks like a blank page with a pencil on it. So click on that, and that will open up a 2D building environment. So before we look at our 2D sketch environment, maybe just a word about 2D in general. If you have a 2D building program that you use, whether whatever that may be, the most common and probably ubiquitous is ChemDraw, but there are other options as well. We certainly rely on ChemDraw. That's a great program for building in 2D. If you've got access to that, just use it. So I'll just demonstrate. Use ChemDraw, and then you can just go to the File menu, Open, and anything that you've saved. This is just a folder with some ChemDraw files. Anything that you've saved as I think it's .cdx or .cdxml are the options you can open in Spartan. And we will open that and then do a minimization, put it in 3D, just do a molecular mechanics cleanup and put it in 3D like we would from our building environment. In 3D, but you can certainly go and look at that in 2D as well. Again, our 2D environment is intended as an input, so it's not as polished as programs like ChemDraw that are intended to provide publication quality 2D images. Okay, enough about that. Let's go now to talk about how the 2D sketch interface is designed. Okay, let's close this existing file and we will get back into the 2D sketch mode. And let's just describe, as you drop into the 2D building environment, the atom carbon is selected, and let me just describe the layout. So basically we have the sort of upper right corner of the periodic table, organic elements. So hydrogen, boron, carbon, nitrogen, oxygen, fluorine, all the halogens, so fluorine, chlorine, bromine, and iodine. And then just silicon, phosphorus, and sulfur. If you want anything else, you just go to More. You can go to the periodic table and grab from the rest of the periodic table. The More also has a shortcut to some functional groups. And then for organometallic systems, there are a set of ligands that are available. And then there's substituents for building virtual libraries as well, just a few of those. And those aren't really, we'll demonstrate those in 3D at a later point. Okay, so you can access elements outside of what are included. And then there are just a short set of rings which include benzene, cyclohexane, and then a few different variations as far as attachment points. And then there's just an icon for, at least at this point it shows cyclopentane, but I think the 3, 4, 5, and 7 member rings are represented in this menu. And then a set of functional groups, just common functional groups, so carbonyl, carboxylic acid, or it could be ester, depending on the attachment point, and then amide, and then could be also formamide, depending on whether you're bonding over at the carbon bonded to carbonyl, or if you're bonding on the actual nitrogen. Okay, so general building. So with carbon selected, let's go ahead and close the existing file from the close folder icon. You can also do that from the File menu, Close. And I won't save changes, and either from the File menu, New Sketch, or just the blank page icon with the little pencil on it, so to the upper left. Let's re-enter the sketch mode, and let's just talk about the layout of the sketch palette before we begin building. So from the periodic table, in the upper left corner, we have hydrogen, and then basically the other atoms included are from the upper right, starting in the second row. So boron, carbon, nitrogen, oxygen, fluorine, silicon, phosphorus, sulfur, chlorine, and then 2 additional halogens, bromine and iodine. So basically the organic set. of elements. And then if you need anything else, you can click on More, which is in the upper left, sort of under hydrogen and boron. If you click on More, that's a shortcut to a menu. And from there, you can jump onto the periodic table, so you can access the rest of the periodic table. You can grab a set of functional groups. And if you're doing organometallics, there are a set of ligands. Substituents is essentially a partially implemented 3D functionality, and that'll be demonstrated later. But just you can access additional building pieces in the More menu, so that's accessible under hydrogen and boron. And then just to talk about the remaining layout as far as building goes, benzene, and then cyclohexane, and then cyclohexane. If you double click on this, there's some attachment points, either axial or equatorial. There's a set of rings as well, I think 3, 4, 5, and 7, and depending on what you have highlighted, I think the default is pentane, but those are all available underneath. And then just a small set of functional groups, so carbonyl or carboxylic acid or ester, depending on where you attach, or an amide or a formamide, depending on where you attach. Okay. And let me just point to a couple other pieces. So there's wedges and dash wedges for indicating stereochemistry, or if something is relatively in front of or behind an atom. And then this indicator that says basically single bond just tells you how we build. So I'll do a quick demonstration, and then we can move beyond that. The initial build is typically like you would with a pencil. You sort of put it down and then you draw, so it's kind of a drag. So if I sort of do a zigzag pattern, I now have 4 atoms connected with 3 bonds, and every vertices or every endpoint is a carbon. Okay, and then there's, in this 2D sketch mode, this little broom is kind of a 2D cleanup. It's sort of a 2D minimization. It's not exactly an optimization, but it'll sort of clean the structure up a little bit. Okay, so with butane on screen, let's talk about a few additional building options. Okay, let's use butane to demonstrate some standard mouse operations. First, if you depress the left mouse and move the mouse button up and down, you'll rotate. So rotate in the plane of the screen. Right mouse button depressed, either left or right or up or down, will translate. And then the center mouse wheel is used to zoom in and zoom out. Okay, so let's use butane, and we'll just use this as an example to demonstrate some sort of standard building functionality, in particular the substitution functionality. So we have on screen butane, but if I wanted propylamine, for example, I could just click the adjacent nitrogen and then double click on a terminal carbon to substitute. Okay, so it's just a double click to substitute. I use the undo button to the right of the view mode in order to revert back to the carbon. Let's say we wanted propanol instead. Okay, so you just double click to replace. Or I could do click on carbon, double click and replace this, so it would get us back to butane, and say, oh, I wanted the ether actually. I wanted the oxygen substitution at the 2 position. So you could just either replace with carbon or do an undo and then go and do a replacement at whatever carbon you want. Okay, so pretty standard for the atom replacement. Let's just look quickly at bond replacement. I rotate this around a little bit. So if we wanted trans 2-butane for butene, for example, there are a couple ways to do that. You could click on carbon, and you could specifically click on the second carbon and then drag a new bond over to the 3rd carbon. That's one way to do it. That's easy enough. But even easier is if you simply just double click on the bond, and that will elevate its bond order. Okay, so this is true from single to double, double to triple, and then this isn't cleaned up or optimized in any way. Actually, we could do that with the cleanup functionality, which is a little broom icon to the right of the trash can here. Let me just click that. So that would make the 2-butane linear, as you would anticipate. Let me do undo, and then we'll go back to let's see, with carbon selected, we'll go back to butane. Okay, so bond substitution, pretty straightforward. I don't think, let's see, cis trans. Okay, so let's say this was trans before. Let's say we wanted cis. we'll just, with carbon selected, I'm just going to draw a new carbon out, and then I'll just delete the previous carbon. It's a double click to delete. So, you could, to go from cis to trans is pretty straightforward as well. Let's see. Okay, so we've done atom substitutions, bond substitutions. Let's look at ring fusing quickly, and this behaves, I think, as you would anticipate in the 2D mode. And let me just demonstrate ring fusing quickly before we get into the general building examples. So I just clear this, and with regard to the insert, the initial build motion, just like in the 3D space, it's a double click if you're inserting rather than drawing. So double click to insert would be to insert benzene, and then if we want to make this naphthalene, just double click an adjacent bond or one of the bonds. So naphthalene or whatever comes next, anthracene, tetracene, etc. The same is true with regard to the saturated rings. So if you do cyclohexane, you want to build transdecaline or whatever, you can do that. If you want to add a 5-member or 4-member ring on, you can do that as well. So if I wanted to build a steroid scaffold sort of quickly, you can do that. Off the top of my head, it's something like this. Okay, and then you can go and decorate things from here. Okay, so fusing rings, similarly to the 3D mode, you can fuse rings, and it makes a lot more sense. It's easier to work with in 2D. Okay, so now let's look at the general building examples from the tutorial number 4, and those, again, just to remind everyone, those are located in the activities menu, tutorials, and we're on tutorial 4, sketching organic molecules in 2D. And the first example that we'll do is what? NN-dimethyl aniline. Okay, so we'll do this right here. So just a phenyl ring with an amine, and then a couple of methyl substitutions. I'll demonstrate this. Okay, let's go ahead and build N-dimethyl aniline. And first, let's clear what's on screen. We'll just click on the little trash can icon and do a clear current sketch and say OK. And then this is easy enough. We'll just go to the benzene ring or the phenyl group towards the top of the rings menu. Just select that, and then it's a double click with the left mouse button, double click to insert. Okay, so we put benzene on screen, and you can use the center mouse wheel to zoom in and out, and the right mouse to move to translate. And then let's just go over to the 2D sketch builder again, and then grab nitrogen from the available elements. And I'm just going to choose the carbon at top. You can pick any one. I'm going to choose the top carbon and then just drag up. And this will insert aniline, so NH2 here. So this is aniline. And then we'll just move over and choose carbon, and this will add a couple of methyl groups. So just click on the nitrogen and sort of drag up to the left and up to the right. So 1 and then 2. So we have NN-dimethyl aniline, and we can use the little broom icon to the right of the trash can. It's a sort of a cleanup. It's supposed to be a sweep, like a cleanup operation. So that'll tidy up the bond angles in 2D. It's sort of a 2D minimization. Okay, so NN-dimethyl aniline. All right, let's see what's next. Stilbene. Okay, trans-stilbene. Actually, I think this is a precursor to resveratrol. Yeah, I think actually the anti-inflammatory, maybe heart-healthy red wine resveratrol molecule has a trans-stilbene substructure. Maybe we'll look at that in just a minute. Okay, so let's build trans-stilbene. In order to do that, we'll clear the current sketch. And then I think the easiest thing to do is carbon is already selected. So let's just drag ethane on screen. So just click and then drag and release. That'll put in ethane, 2 carbons with a single bond, and then double click to make that ethylene. And this is trans. So we're going to grab the benzene ring at the top, and we'll go down and to the left to insert, or to drag a sort of a phenyl group, and then up and to the right in the trans position, up and to the right. So you can see down in the lower right it says trans-stilbene. Here, let's quickly undo that. Let's build cis just to demonstrate. So if we wanted to build cis, we would just go down and to the right instead of up and to the right. Just relative if we're on the same side or the opposite side of the double bond. Okay, so cis-stilbene. Okay, we'll go back to the trans, and then we'll just confirm. You see the name in the lower right, so that sort of means that I'll click the broom icon to clean it up. If you see the name in the lower right, that means that Spartan recognizes it in the Spectrum Properties database, assuming you have that installed. And that's part of the Spartan 24, and sort of every research version of Spartan includes the SSPD. But that's only about 315,000 structures, or however many. So probably you need a better source to check. So let's go. We recognize this molecule, but let's go to the molecule properties dialog, and I'll just demonstrate PubChem, the connection to the NIH PubChem site again. So I clicked on the properties icon. You can get to properties by right-clicking and choosing properties from the contextual menu, or the display menu has a properties entry as well. At the bottom of the properties dialog, under the molecule properties tab, you'll see there's two buttons, sort of Wikipedia and then PubChem. So we're going to search PubChem, so we're going to click PubChem, and what that'll do is an NIH search of the PubChem site based on INCHI. So based on the INCHI string of what we drawn, and you see trans-stilbene here. Okay, so that's a way to confirm. And then I want to see, let me close this if I remember. I think there's just hydroxy groups, like OH groups. One is sort of para, and then I think ortho and meta. Okay, let's see. Okay, yeah, so Spartan recognizes this molecule down here, and it's maybe attempting to give an IUPAC name. I'm not really sure. But let's go back to PubChem and do a search again as well to confirm. Okay, resveratrol. Okay, so just you can use, I only point to PubChem as it's a huge resource. I don't know how many millions. there's hundreds of millions, I think, of molecules included. So it's a great resource to access just for confirmation. Did you build what you think you built? So that's one thing you can use it for. Okay, let's go ahead and see what's next. I'm clicking on this lower in the sort of dock at the bottom on this PDF indicator. You can also get there, same place, activities menu and tutorials, and then it's the sketching organic molecules in 2D, so it's tutorial 4. So what's next is Indigo, and this I keep opening the tutorial just to refer to the next build. Okay, so we'll build Indigo. This is interesting. Let me just move this off screen. We'll go ahead and close the properties dialog and close the resveratrol example. Okay, probably the easiest way to build Indigo is to let's go to the ring selection, and not benzene, but let's go down and let's choose cyclopentane. If you don't see cyclopentane, double click on whatever the bottom icon is, and you'll see a 3, 4, 5, and 7 member ring are available here. So with cyclopentane selected, just what you'll do is double click on screen, and just pick one of the vertices and click and then drag out. So basically we'll build like a cyclopentyl cyclopentane. So basically a single bond connecting two cyclopentane rings. Okay, and you can use the center mouse wheel to zoom and rotate around or however. Okay, and then let's go ahead and there's some substitutions that we need to make. So let's go to the bottom, so just to the bottom of the attachment point. Let's go down and let's make this a doubly bonded oxygen. So right now this is an sp3 carbon, and what we'll do is we'll choose oxygen and we'll just drag out, and initially that would build an OH functionality, a hydroxyl group, but instead what we'll do is we'll drag on that again and we'll make this a carbonyl. And let's do the same thing. Let's move across the attached bond. And let's go ahead and make this a double bond now, because eventually that's going to be a double bond anyway. I just double click to make that a double bond. And then what we'll do is we'll come up here and do the same thing. Let's go drag up and then drag up again. Okay, so we'll make a carbonyl functionality up here and one down here. And then let's go to, let's choose nitrogen just to the left of oxygen, and then just a double click. To insert an amine here, to do a replacement, replace this sp3 carbon with an sp3 nitrogen. Okay, and then the last piece to complete will be just choose the phenyl functionality or the benzene ring, and then we're just going to do like a fuse rings operation. So just double click on the opposite side of the double bond, just double click on the bottom of the 5-membered ring, and do the same thing on the other side. Okay, and here's indigo, and then again you can always clean up the positions by clicking on the broom icon. Okay, let's see what's next. All right, we go ahead and close indigo or clear what's on screen. I should just mention at the end of each one of these building operations, in principle, you click on the glasses icon, you move into 3D, and then you begin operating with the calculations dialog and anything else in the 3D space. Okay, back to, let's see what's next. We'll look at 3-cyano-4-methyl cyclohexenyl radical. Okay, so we start out with cyclohexane. Let me make that a little bit bigger. That's not the best resolution. We'll start out with cyclohexane. We'll add a methyl group here. We'll add a double bond here, and then we'll insert the cyano functionality. And then finally, at the 3 position, we'll go in and modify this at the end with a little radical indicator. Okay, so let's take a look. We'll start out with cyclohexane. So go over to the rings, and then it's the middle sort of item, cyclohexane. Double click on screen, and just click on carbon, and just go to the top carbon. Just drag up, double click at what would be the 1-2 position, and I already have cyano selected, so I'm just going to drag out. Let me show you where cyano is. This is in the more. It typically would say more when you initially open it, but this has a shortcut to the periodic table, groups, a set of ligands, a set of substituents, but we were in the groups and I had chosen cyano. Okay, so now the only thing left we need to do is just modify this functionality here at the 3 position and make this a radical. So I'll click the broom icon just to clean the structure up, and then immediately above the broom you see there's a little icon for radical. And if I click on that to select it, it's now something that will toggle. You can move through it. So it's either a radical, or it's a cation, or it's an anion. So depending on what you have selected here, you can go and make a modification. So with radical selected, we just double click here, and the structure is complete. Okay, let's see what's next. Okay, next building example is androsterone. So we'll do a steroid. Let me make this just a little bit bigger. This looks a little bit more involved, but it's actually pretty easy to deal with the 2D sketch builder. So we'll start with a cyclohexane, so a 6-member ring, and we'll fuse 2 of those, and then we'll add a 5-member ring, and then we'll go in and modify things to make a carbonyl functionality towards the top. We'll have to deal with the stereochemistry interfaces between the rings, so we'll put the protons appropriately above or below the plane. There's an OH to deal with that's pointing down over here. So we'll take care of the stereochemistry after we build the scaffold. And this is pretty straightforward. So let's take a look. I'll move this off screen. Let's go ahead and close the previous example, that radical. And start with cyclohexane. So move to the rings column in the second entry, cyclohexane. Just double click on screen. And keep it large enough that you can see it, but give yourself a little bit of space. On the right-hand side of the 6-member ring, just double-click on that bond, and that'll fuse an additional 6-member ring on screen. So we have transdecalan on screen now, or decalan. We haven't really defined the stereochemistry yet. And then double-click again here on this bond, and we'll insert a third, or fused a third ring. So 3 6-member rings, and then let's choose this 5-member ring, cyclopentane. If this isn't selected, just click on it and to sort of bounce this down, and you can select their 3, 4, 5, and 7-member rings available. So with cyclopentane chosen on the right-hand side here, go ahead and double-click. All right, so this will give us the steroid scaffold. And then we'll go ahead and decorate things. If you remember, in the upper right sort of area up here at the top of the 5-member ring, this is like the 17th position of the scaffold. There's a carbonyl group. So I'll start with an OH and then just double click on that bond to make it carbonyl. So we go from OH to doubly bonded oxygen. Okay, and then keep oxygen selected, but you'll see we had just a single bond or no differentiation for stereochemistry. Move to the dashed the hashed wedge. Okay, so this is sort of stereochemistry pointing down. Okay, we're going to point at the bottom of this first 6-member ring here at this 3 position. We'll point down. Okay, put a OH functionality pointing down, and then we'll deal with the protons. Okay, so the hydrogens that are we need to just define the stereochemistry on these rings. So let's go choose hydrogen, and let's also make sure that the that this dashed stereochemistry wedge is down is selected as well. So for down, and between the first 2 6-member rings, let's put a hydrogen here. Between the second and the third ring that we built, let's put a hydrogen pointing down here, and then also between the 5-member ring at the end and this 6-member ring, let's put a hydrogen going down here. Okay, there's one more proton to deal with. This one is sticking up, and it's at the interface of these 2 6-member rings. So I'm going to choose the solid wedge, and we'll just put that up. So a proton here. And then there are 2 additional methyl groups that are in the up sort of stereochemistry position, and those are located here. Oops, I only have a single bond selected, so let me go and drag over that again. So we'll put a wedge indicating up for a methyl group here, and then there's one other basically at this position, the interface of the first 2 rings. Okay, and if I've drawn this correctly, let me click the clean up button, the little broom. You'll see in the lower right corner the name androsterone appears. We can also go and check that in the in PubChem. If you click on the properties icon, you can go to the PubChem entry and see if it does an entry search and it's androsterone. Yeah, so we built it correctly. Good for us. Okay. Okay, so that will conclude the 2D sketch examples. And I mean, essentially, the 2D builder is ideal for getting things into the 3D environment. We're not suggesting it makes the prettiest pictures. Certainly use other tools for things like that. Certainly ChemDraw is one of them available and is a good one. So use that, but use our 2D builder if you don't have access to that, or if you just need something quick and dirty to get a 2D sketch converted into 3D. Okay, so with that, I think we'll close the tutorial. Actually, I'll just leave you with where we'll pick up next time, which will be the 5th set of tutorials, and that's under the Activities menu, Tutorials. And yeah, let me make this just a little bit bigger. And so this is Spectra and Properties of Organic Molecules from SSPD, SSPD being the Spectra and Properties database. So this is where we'll pick things up with the next tutorial.